Present-day spaceships, no matter if they're meant to carry people or not, are powered either by solar energy or chemical fuel, or a combination of the two. But if we are to expand humankind's first-hand reach into the solar system beyond the moon, we need new, better, and more effective means of propulsion. Like, say, nuclear. Solar energy propulsion for spacecraft has a number of advantages, but also a series of downsides. It works wonderfully, but only if enough sunlight can reach the ship. The same happens with chemical propellants, which are effective, but they require a lot of mass and are not particularly fast. Knowing for a while now that it's going to head for Mars and elsewhere, NASA started not long ago looking into nuclear power as a means to push spacecraft, more specifically into something called nuclear thermal propulsion, or NTP. The concept requires a uranium nuclear core where atoms are split to release heat, and a fuel like liquid hydrogen, which is sent into the same core to be turned into gas by the said heat. The gas is then shot out the back of the spacecraft, generating thrust. There are several obstacles standing in the way of NTP engines at the moment, but several companies are working on solutions to them. General Atomics, for instance, is looking into how nuclear fuel can survive after thermal cycling in hydrogen representative temperatures and ramp rates. But what does that mean? You see, the nuclear fuel used as an NTP reactor will have to survive the high temperatures in the core, but also the effect of the hot hydrogen gas resulting from the reactor's operation, including erosion and degradation. Without naming the nuclear fuel it used, General Atomics says it put it through its paces at the NASA Marshall Space Flight Center in Huntsville, Alabama, thus becoming the first company to use the Compact Fuel Element Environmental Test Facility there to demo the survivability of fuel. Several high-impact tests were performed on location, with the fuel being subjected to 6 thermal cycles. Each cycle gradually increased the operating temperature, reaching a peak of 4,220 degrees Fahrenheit, almost half the temperature of the sun's surface. The requirements of the tests called for the fuel to be kept at these high temperatures for 20 minutes at peak performance. Not only was the fuel under scrutiny, but also the shielding of the precious substance. General Atomics says the tests were a success, as the nuclear fuel survived these conditions, and that they are a critical milestone in the development of an NTP reactor. It's unclear, though, when we'll get our hands on the first one. Generally speaking, NTP reactors have the capacity to allow up to 3 times more effectiveness that rocket engines power by chemical propellants. That could translate into a reduction of the required journey time to Mars to about 7 months, as per the Office of Nuclear Energy, compared to a minimum of 9 presently required.